scatter plots, making predictions. In this example, it's showing a scatter plot of the amount of times a cricket chirps and the degrees outside in Fahrenheit. It says a researcher studied the relationship between the number of times a certain species of cricket will chirp in 1 minute and the temperature outside. Her data is expressed in the scatter plot and line of best fit below. Based on the line of best fit, how many times would the cricket most likely chirp per minute if the temperature outside were 63 degrees Fahrenheit? Now we're going to use this line of best fit to make a prediction for a number that's off the chart. So even though we can count up and kind of move over, we don't exactly know what that number will be. So in order to know exactly what that number will be, we need to write down the data we actually have. So we have 3 data points here. I'm going to start with the lowest. 60 chirps when it's 47 degrees outside. I know that because the x-axis is chirps and the y-axis is temperature. The next point we have is 75 chirps when it's 51 degrees, and the third point we have is 90 chirps when it's 55 degrees. So if we look at the pattern of what's happening here, we can say this is increasing by 15. That's known as the delta x. And the delta y looks like it is also increasing, but this one seems to be increasing by 4. So if I would like to know how many chirps I will get when the temperature is 63, then I need to continue the pattern. So I'm going to fill in some more data here. 55 plus 4 is 59. 59 plus 4 is 63. That's what we want. So if I had to continue this pattern twice, that means I'll also need to continue the chirps pattern twice. 90 plus 15 is 105. 105 plus 15 is 120. So that means I can expect 120 chirps if it's 63 degrees outside. Don't forget to use these purple values to create a table. Find the pattern of the table and then extend it to the number you need to find.